Today now we will discuss about relationship between continuity and partial derivatives. If we compare it with partial derivative of function of two variables, okay, function of two variables. So if we compare it with the function of one variable, in the function of one variable, if the derivative of a function exists, that means that function must be continuous. But the same thing is not with the function of two variable. In function of two variable, if a function, if the partial derivative of a function exists, then function may or may not be continuous. That means a function can have partial derivative with respect to x and y at a point without being continuous at that point. Okay, so partial derivative may exist even though function is not continuous. So this is different than the case of one variable. Okay, so the partial derivative may exist even though function, in that case we cannot conclude anything about continuity. Function may or may not be continuous. Let's do one example now. Yz minus ln z equal to x plus y. Then compute the value of del z over del x and del z over del y if the equation defined z as a function of two independent variables. Okay, so here it is given z is the function of x and y, then compute del z over del x and del z over del y. In this case, it is given as an implicit function yz minus ln z equal to x plus y. This is an implicit function. Why implicit function? Because z cannot be expressed in term of x and y. That means you cannot write z is equal to function of x comma y. Okay, it is an explicit function. If we are able to write z in term of x and y separately, then it is explicit. But in this case, you are having z here and also ln z here. You cannot express z in term of x and y. Then it is called implicit function. So this function is implicit. Now we have to compute the value of del z over del x and del z over del y. So differentiate the whole equation 1 with respect to x. So differentiate equation 1 with respect to x. Okay, here it is given x and y are independent. X and y are independent. Okay, now when we differentiate it, then y, we are differentiating with respect to x, so y is constant. So del z over del x, z is a function of x and y, so we are getting differentiation of z with respect to x, that is del z over del x, minus y is constant, so obviously we will write ln z, that is 1 upon z del z over del x, and differentiation of x is 1, differentiation of y with respect to x is 0. So from here we can compute del z over del x, that is y minus 1 upon z equal to 1. Okay, so del z over del x equal to 1 upon yz minus 1 into z. We simplify our equation, then we are getting this result. Similarly, we can compute del z over del y. Okay, differentiate equation 1 with respect to y. Now, z is a function of y and here x is constant. So, y del z over del y plus differentiation of y is 1, okay, z as it is, plus minus differentiation of ln z, that is 1 upon z, and del z over del y equal to differentiation of x with respect to y is 0 and differentiation of y with respect to y is 1. So from here y del z over del y minus 1 upon z del z over del y, we will collect like terms together, equal to 1 minus z. Okay, and y minus 1 upon z del z over del y equal to 1 minus z. Now compute the value of del z over del y, that is 1 minus z upon zy minus 1 into z. So this is your answer. So we can compute the value of del z over del x and del z over del y by this procedure. Now let's do next question. Function is given as fxyz equal to x sine y plus 3z. Okay. Now compute the value of fx and fy. So del f over del x equal to, we are differentiating f with respect to x. So it is a function x sine y plus 3z. So differentiation of x with respect to x is 1, sine y plus 3z is as it is, plus x as it is, differentiation of sine xy plus 3z, that is cos y plus 3z, and differentiation of y is 0 because y is constant when we are differentiating f with respect to x, plus 3 del z 3z over I think it should be 1x. Okay, it should be x. Let me do it again. There is a little bit confusion. Let me write it again. Okay, so function is what? X sine y plus 3x. Okay, del f over del x. So differentiate with respect to x. Differentiation of x is 1, sine as it is, y plus 3x. Plus, now x as it is, differentiation of sine. It is cos y plus 3x. And the differentiation of y plus 3x is what? Y ka differentiation 0, plus 3, differentiation of x is 1. So from here what we are getting, sine y plus 3x plus 3x cos y plus 3x. So this is the value of del f over del x. Similarly, we can compute del f over del y. Similarly, let us compute del f over del y. X as it is, because as x is constant, now differentiate sine, it is cos y plus 3x. And differentiation of y is 1. 3x is constant, so it is coming out to be x cos y plus 3x. Okay, so this is the value of fy or del f over del y. So this is the procedure how to compute del f over del x and del f over del y. Okay, let me ask one more example. F is equal to y sine xy. Fxy equal to y sine xy. And compute fx and fy. So del f over del x will be what? Y, differentiation of sine xy, it is cos xy because it is a function of x. And differentiation of xy now, it is differentiation of x is 1, y is constant. So what is coming out to be y square cos of xy. Similarly, compute del f over del y. That is, differentiation of y is 1, sin xy as it is, plus y as it is, differentiation of sin xy. It is cos xy into differentiation of xy. X is as it is because it is a constant when we are differentiating y with respect to x, y, and the differentiation of y is 1. So this is sin by xy plus xy cos of xy. Okay, this is del f over del y. Okay, so it's very simple to compute partial derivatives.